Thank you for joining us for today's webinar, ISO certification, more than a stamp on a package. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to mapedigital@mapei.com. We also invite you to visit our MAPE Technical Institute pages on our website, www.mapei.com, where just about every MTI video features today's speaker, Sam Biondo. Sam is MAPE's National Technical Presenter. He has more than 25 years of international installation experience in the flooring industry. As the host of MAPE's popular MTI TV series of videos and as a speaker at many industry functions, Sam combines installation expertise and his real-world knowledge to help audiences easily comprehend new innovative technologies and their applications. And I'm very happy to welcome him here to this microphone. Sam, the floor is yours.
Thank you, Jen. And that was a really nice intro. My gosh, I think I'm blushing. I don't know. I haven't blushed in quite a long time, so I don't know. But thank you very much. That was very kind. Everybody, thanks for logging in and joining in today. This is an interesting topic, and it was funny. A minute before we even went on the air, we came up with the next version of this particular presentation and what we're going to do. And just to let you guys know, what we're talking about doing is the next time everyone will bring their TCNA handbook with them and a highlighting pen, and we will do a presentation about how these ANSI codes and ISO codes work with different specifications within the handbook and where to find them and how to find them. But let's just start with the basics, and that's what we're going to do today. We're going to go ahead and introduce you guys, for those that don't know, to ISO and ANSI and why certain codes are what they are. So with that, let's get started. And he clicks the wrong thing. Nope, we don't want to end the show. There we go. All right, today's objectives, how ISO 13007. By the way, does everybody know what ISO stands for? I see some people shaking their heads no. I really can't see you, by the way, but I'm just imagining you're shaking your heads no. It's the International Standards Organization. The first letter in that is international. It's global. It's everywhere. It's international. So this is an international standard. It's not an American standard, or it's not an Italian standard, or Canadian standard, or wherever, a French standard. It's international, International Standard Organization. And ANSI, American National Standard Institute. They complement one each other. They work together. They work with each other and they work together. Any true international company as a manufacturer will have their ISO codes on all their packaging. They will have done the testing. And if they don't have them on their packaging, you need to ask them why. Why not? It's been in the handbook, in the TCNA handbook, since 2011. That's quite a minute. That's 10 years ago at this point. What it does is, just in a short version, it's the right product for the right application. So it's more like a customized product for your job. Whereas like when we're talking about an ANSI 104, it's a bigger, it's like a do-all product. Whereas these are more specific to your applications. And you'll see what we're talking about. Anyways, further moving along, understanding ISO 13007 classifications, the explanation of the chemical makeup, the measurable performance, and the optimal characteristics. Recognizing the advantages of 13007 classification system in specifying materials and having materials specified. And looking at products and going, these three products meet that specification. I like that one in the middle there, or I like this one. It narrows down. Not only do we have a plethora of products available, but so do other manufacturers. We're not the only ones in there. So, oh my gosh, stop this. There we go. So in the tile setting material standards, ANSI A118, we're going to talk about A1181 dry set mortar, A1184 modified dry set mortar. That means it has latex in it. A118.11 EPG exterior glue plywood latex Portland cement mortar. That means it's designed to bond to exterior glue plywood. And the new and improved 118.15. And that's really where I'm going to put my emphasis on this, but we'll cover all of these. So the 118.5 difference between that and a 118.4 mortar basically is heat aging shear bond tests and the value of the heat aging tests. What it does is it's just not about cement. It's also about latex. And by the way, latex is the expensive thing when manufacturing a product. So the standard for doing this is to meet a 2x2 porcelain tile bonded together, 1/8 inch of mortar offset. Specimens are cured 14 days at 70 to 77 degrees, followed by 14 days at 158 degrees in an oven. It's a heat aging. It accelerates the drying. It accelerates what's going to happen to the product. And then they do a shear bond. Now think about this. You've got these two pieces of tile and they're sheared or skewed together like this, and they put it on this machine that just mashes it. What I don't want to see is these two things separating like an Oreo cookie. I want to see this thing crumble and break, because if they separate, then the failure was within the mortar. So the shear bond must be greater than 400 PSIs. This is important because a lot of people can meet most of the ANSI 118.15 standards. When it comes to the shear bond, the heat age shear bond test, this is where they get tripped up. They just think by adding some more cement in there, they've increased the bond strengths, they've increased all the other testing methods. But this right here is what separates a 1.5 product to a non-product. And by the way, when we're talking about a standard, you can't mostly meet the standard. You either meet the standard or you don't meet the standard. It's either a yes or a no. There's nothing else in between there. Do you meet all of the standard, all of the test criteria for ANSI 118.15? It's either a yes or a no. Not, oh, we're three times on the bond strength. You didn't answer the question. Mapei currently has 10 mortars that meet ANSI 118.15. This is the testing properties that are required. So what you can see here is you can see a breakdown. So for open time, 20 minutes at 28 days, a tensile bond strength for ANSI 118.1, which means it has no latex in it, 75 PSIs or higher. ANSI 118.4 has latex in it, 75 PSIs or higher. ANSI 118.15, 75 PSIs or higher. Okay, that seems pretty equal. Next test. Test duration and conditions. 7-day glazed wall shear strength, 7 days. Shear bond test, 200 PSIs, 300 PSIs, 450 PSIs. So you see now, by adding more cement to the product and doing nothing else, you can go ahead and beat that test and increase that test. Okay, shear bond test from tile to tile. 7 days dry cure, 150 and 200, and the ANSI 115 is 250. 28-day heat aging test. They don't do it, and it's not required for ANSI 118.1 or ANSI 118.4, but for ANSI 118.15, 450 PSIs. 1-day shear bond test, it's 100. So you can look all the way across here, and you can see every time the number is higher. 100, 150, 200, 150, 200, 400. 175, 250. This is a premium product. That's what this is telling you. This is a rock star of rock star products. This is an ANSI 118.15 product that meets all of those standards is the premium product. And thinking about the size of tile and the conditions that things are being installed in, maybe, just maybe, I want to go with this product right here. So mortar designations, there's ANSI 118.1 for 115T. These are all conditions that are added, designations that were added, and basically they were influenced by the ISO codes that you're going to take a look at in a minute. So now they have an extended open time. Now they have one that identifies a fast set. In the past, you were counting on a manufacturer to tell you this was a rapid setting product, but really you didn't know what the code was. You didn't know what was what made it rapid setting. Now there's a standard for it, and you can go ahead and see the F for fast. You'll see a product ANSI 118.4H, large and heavy tile mortar. Anything with an edge 15 inches or greater is considered a large and heavy tile. Well, most of the tiles, not the tile in the picture by there, but most of the tiles that you're installing these days, they certainly are bigger than 15 inches on one side. Think about all those planks. All those planks qualify under the large tile mortar standard. And T stands for thixotropic, sag resistance, the ability to hang a tile sideways on a wall or on a ceiling, to go ahead and knock the ridges down, to move it, but when you stop pushing and pulling on the tile, it stops moving. That is really important. It doesn't continue to sag on down. So there could be an ANSI standard that looks like this, ANSI A118.4 TE. T stands for thixotropic, which means it's non-sag, and E stands for extended open time. So now you're getting a specific qualified product for your job. If you're doing a floor, you might not need the thixotropic properties. If you're doing a large and heavy tile, then you might need the thixotropic properties, or you're going to need something that is A118.4 HE, where it's a heavy tile and extended open time, or you might need one that's an HF, that's fast setting. In the ISO classifications, it's based on performance. So there's the chemical nature, whether it's cementitious, a dispersion, which is mastic, or resin reaction, epoxy or polyurethane. And it's a series of letters and numbers. And these letters and numbers combined tell you what the product does. So if it starts with a C, it's cementitious. If it starts with a D, it's basically a mastic. And if it starts with an R, it's either epoxy or urethane. Then there's performance levels. There's a 1 and there's a 2. And 2 is doubled in performance levels. So here are the standards right here. A starts with a C. C stands for cementitious. Then there's normal and improved. And the special characteristics are fast setting, slip resistance, extended open time. Now they go with deformable and highly deformable. You're going to see a test, pictures of a test, and what determines the deformability. But it's the ability for product to bend and flex without cracking and breaking. Then they have a P1 and a P2. It can bond to plywood, and it could really bond to plywood. And why do I need 2 designations for plywood? Well, I know I live in Florida and most of our installs are slab on grade, but I also travel the country and I see a lot of places where it's multi-level wood construction and you have plywood on the floor and then you have plywood up on the next floors. In a commercial type building, a restaurant on a second floor of a building, anything like that, you might want to go with improved adhesion. So you might want to go with a P2. Mastics are under D, dispersion. The water gets dispersed out of the product, and that's how the mastic bonds. So it's a dispersion, so that's D. And there's normal and improved. And then there's accelerated drying, there's fast drying. There is slip resistance and extended open time. Then R stands for reaction resin, which covers epoxies and urethanes. They don't separate the two. And 1 is normal and 2 is improved. And T stands for slip resistance. Then it also covers grouts. CG stands for cement grout, again, normal and improved. And then there's also special characteristics, or F, A, or a W, fast setting, high abrasion resistance, or reduced water absorption. Now you're thinking to yourself, why do I need high abrasion resistance with a product? You ever think about a fountain that has glass tile in it and you're using a cementitious grout? As that water's flowing over that lip of that fountain or that water feature, it's basically constantly rubbing up against the surface of the glass and through the grout joint. Does anybody know how the Grand Canyon got made? It started with a little drip, and then water just eroded that Grand Canyon. That's what's happening in a water feature. You need high abrasion resistance from that water so it doesn't wear out the grout in that grout joint. And then RG stands for reaction resin grouts. So we're talking about epoxies and polyurethanes. This is just another chart, one more time, just showing you how it works. So let's just say you have a product A that starts with a C, so it's cementitious and it's improved and it's highly deformable. It would look here. I'll do you one better. Can everybody see that? Can you see right there? It says C2TE. So C stands for, that's right, I heard you say it, cementitious. 2 stands for improved. You guys are getting good at this. T, right there. Sag resistance is thixotropic. And E stands for extended open time. So I have a product that has good bond strengths because it has improved cement in it. It's thixotropic. It's not going to sag if I use it on a heavy tile on a wall. And it's extended open time. S1. S1 stands for deformability, so it has flexibility. So I can use it in a place where there might be some movement, expansion and contraction. In a bathroom where you're turning the hot water on, you're turning the hot water off. And P1 can bond to plywood. So this spells out everything that the product can do. Also, over here are the ANSI codes. So it's ANSI A118.4 and ANSI A118.111. Now, there's a whole purpose to this, and I'm going to show you why these are important. First things first, C1, where normal adhesion strength is acceptable. Think about this. I got a 12 by 12. I got an 8 by 8 standard Monica Tor single fired clayback tile. I'm putting it in my grandmother's foyer at her condominium down here in South Florida. Do I really need like super superior bond strengths? No, I don't. I need a product that's going to work. Class 1 tensile strength adhesions is 72.5 PSIs after 20 minutes. When we're talking tensile strength, we're talking pull tests is what we're doing. We're going to take a metal block and we're going to glue it on top of there onto a tile that's cut 2 by 2. And we're going to set that tile. We're going to glue it on with epoxy. We're going to let the epoxy dry. Then we're going to go ahead and do the pull test. Whereas a C2 is 145 PSIs or greater after 20 minutes, the exact same test. So now I'm thinking shopping malls, airports, I'm thinking almost everywhere. A C2 just has better bond strengths. And this is what I'm talking about on the testing. You can see these blocks right here, and you can see the mortar. And the tiles are set in the mortars. There's the tiles down there. Then these metal blocks are put on top of there. Then there's a bolt that gets screwed into the top up here. And this machine right here does the pull testing. If you look carefully right here at this one down here, you can see the bolt on there. This machine grabs that bolt and lifts and measures the resistance it takes for it to pop loose. And that tells us what the shear bond strengths are. Class E is extended open time and tensile strength of 72.5 PSIs after 30 minutes. Here's the next thing I want you to see. When we're doing testing, this is an ISO block. I wish I had a bigger picture, but I don't. This is an ISO block right here, and it's a standard industry block. Everyone in the industry that's doing this kind of test uses the same block. You want to let them acclimate for 90 days in your facility because they come over on boats and they can pick up moisture in the process. The one thing you're trying to do in testing is control all the environments so you only get the proper reading from the actual performance, in this case, of the mortar. So what they do here is we're going to go ahead, we spread mortar on the back of that tile, then these little on the back of that ISO block. Then we take these little 2 by 2 tiles that are pre-cut and we set them down. Now you look at the first row right here. We waited 5 minutes before we set those down into the mortar. And when we put the tiles down, by the way, we have weights and we put the tile down and we set the weight on top. So you don't go ahead and mash it and push it in harder. Everyone installs tile just a little bit differently. So by having a controlled weight on there, we get the controlled amount of pressure every single time. After 10 minutes, we set the next row. After 20 minutes, we set the next row. And after 30 minutes, we set the next row. So when you see something has a 30-minute open time, that's because it's been tested and proven that after 30 minutes, we still get good bond strengths. But more importantly, this first row, they flip the tiles over after they put them in. So we wait 5 minutes, we set all of these tiles here, we take this end tile and we turn it upside down. Look at the coverage on the back of that tile. Now remember, nothing different was done with this tile, this tile, this tile, or this tile, other than we let the mortar exposed for that amount of time right there. So after 5 minutes, I have complete coverage. After 10 minutes, you can see I don't get as nice a coverage. After 20 minutes, I'm only on the ridges. And after 30 minutes, even the ridges, I don't have good coverage. So guys, another thing you need to be conscious about is, how long is it going to take you after you spread the mortar to put down what you have to put down? Do you got to make a lot of cuts? You might need a product with extended open time for that. So that's how we know. This test right here is how we know how well the product works. But just for your sake, you might want to think about that, because just look in the difference between this tile and this tile with nothing different done except that there was a 25-minute difference in when I put them down. I can see how there could be a problem here. F stands for fast setting. I mean, it's just a rapid setting product. Fast setting adhesives, tensile strength, adhesion strength after 6 hours with an open time of at least 10 minutes. And again, we're back to 72.5 is the minimum. T stands for thixotropic. Slip resistance adhesives must not allow a tile applied on a vertical surface to slip more than 0.5 millimeters or 0.0196 inches, which is about the 2 hairs combined. It's not a lot, and there is a way of testing it. So if we're doing large tiles, you might want to look, especially on a wall, you might want to look for a T-class product. Also, if you're doing floor and wall, you might want to just buy one product. You can use a thixotropic product on a floor, and you can use it on the wall. But if you send out 2 different products and you might get confused, or there might be a mix-up and you might wind up with the wrong product in the wrong spot. And polymers are what make mortars deformable. Latex polymer additives, that's pretty cool, because that is a picture, a microscopic picture of latex and within the cement matrix, and showing the flexibility and what it's doing. It's just like sticky bubble gum, man. Latex polymers wrap around the sand and the cement particles, liquid latex polymers and dried latex polymers. So we're talking about a liquid milk that we're adding, not milk that you drink, a latex milk. Dried latex powder is basically powder that's already mixed in with your product, and you mix it up, you add water to the mortar, and you mix everything up. By the way, this is exactly why you want to let things slake. Give it that 5 minutes. You mix the product up and then just let it sit there in the bucket. This product gets dispersed everywhere, wraps around all the particles, gets in all the nooks and crannies inside of the matrix of the mortar that you're mixing. And then you go ahead and you mix it up again, making sure that it's evenly dispersed throughout there. And it improves the performance and characteristics of cementitious mortars, making them more deformable, improving the tensile strength and improving resistance to water and chemicals. Monomers, the building blocks for polymers, small molecules that become chemically bonded to other monomers, like links in a chain to form a polymer. This is the ISO test to find out if you have deformability, the ability of a mortar to accommodate varying movements between tile and substrate. So they make these flat sticks, is basically what they look like to me. They're about an inch and a half wide by about 6 inches long, and they let them cure out 28 days. They stick it on this machine, which is bridged by these 2 pieces right here, and then this bar comes down and presses on it, and it measures the deflection how much flexion there is in the product before it snaps and breaks. And that tells you whether you get an S1 or an S2 rating. So for an S1 rating, it deflects 5 millimeters or 0.2 inches. For highly deformable, deflects 5 millimeters above 5 millimeters or higher to 0.2 inches. For an S1, it goes from 2.5 millimeters to 5 millimeters. That's a lot of movement right there. And why would I select one over the other? This is a great example. So take a look at this mall right here. You got a slab on grade on the floor. Do I need a ton? I don't have a lot of movement. I mean, I get a lot of walking and things like that, but I really don't have a ton of movement. Now, I'm going to go up here onto the second floor, and I have these cantilevered areas and these wide open spaces and these bridges right here. I can get a lot of movement there. So I might want to go with something, that has an S2 class. I can do a C2 here on the floor, but I want a C2 S2. Remember, the S is the flexibility. Up top up here, I want premium flexibility so it doesn't debond. So on one job, instead of me buying, again, 2 separate products, I would just go ahead and pick the top quality product, the C2 S2 product, and put it on the ground and on these other levels to ensure that I don't have any issues. Again, here's a level right here hanging over. So there's movement in those floors and there's constant bouncing, and it can be a real problem. And adhesion to exterior grade plywood. This is class P1, normal adhesion to plywood, and class P2, a tensile strength of 1 Newton or 145 PSIs or greater, whereas tensile strength on a P1 is 72.5 PSIs or greater. Now you're asking, dude, what is all these numbers about and all these letters about? Why is this even, how would I even know what the heck to do and where the heck to use this? Well, guess what? TCNA handbook. You got one of these? Do you have one of these? You should have one of these. These are here to protect you. These are here to help you make sure you make the proper decisions. You're going to get blueprints or takeoffs, and it's going to show ceramic or glass tile, cementitious bond coat, unbonded mortar bed, concrete on the ground, bonded waterproof membrane, bonded unbonded waterproof membrane, or cleavage membrane. And that's all they're going to say. And you're going to have to fill in the products that meet these qualifications here. So this is an interesting standard. This one, I picked this one because of this. This is on grade or above grade, concrete unbonded mortar beds, waterproof membrane, and in this case, we'll just call it ceramic tile. We'll leave the glass out of it. You're like, okay, well, what's the big deal with that? So first things first, let's go slide over here to the page where it says on ground, Portland cement paste or mortar bed that is still workable for a cured mortar bed. Follow recommendations below to select the appropriate bonding mortar. When a waterproof membrane is placed below the mortar bed, you can use an ANSI 118.1 or better, which means doesn't have to have latex, or an ISO C1 or better. Okay. When the waterproof membrane is placed above the mortar bed, so the first one was below the mortar bed, now we're putting it above the mortar bed. Now you have to use an ANSI 118.4 or better, or a C2S1 or better. You're like, huh, well, that's interesting. When porcelain tile is used, you have to use an ANSI 118.4 or a C2 or better. So if it's not porcelain tile and on the floor, then I can stick with the standard of ANSI 118.1. But if it is porcelain tile, then this changes to this. You see where I'm going with this? Next thing, above ground. Well, it should be the same. No, it's not the same. When a waterproof membrane is placed below the mortar bed, you need to use an ANSI 118.15. Remember that product I showed you in the beginning that had the heat age testing? This is a Mac Daddy product. This has flexibility, superior bond strengths, or a C2S1 or better. When the waterproof membrane is placed above the mortar bed, you can use an ANSI 118.4 or a C2S1 or better. So looking at these and reading these, so now how would you know? You would know and see the ANSI designation of ANSI 118.5. What if you wanted to go with the ISO designation of a C2S1 or better? Well, this is a C2S1, and then it has TE and can bond the plywood. So understanding the codes and understanding where to find them in the book. By the way, these were added 2011. Prior to that, it was just ANSI specifications. And then they went ahead and added the ISO codes from the International Standards Organization. Now, I'm going to tell you, if you go in and look at specifications for a big job, and it's when I say a big job, let's just say an international company, hotels from an international company, Sheridan's and Hilton properties and things like that, you're going to get specifications with ISO standards in them. International companies, they have ISO standards. The A in American National Standards Institute is American. So do you think they use the American standard in France, in Africa, in Australia, they go with the ISO codes. And any true international company that is a manufacturer should have the ISO codes on their packaging, all of their packaging, not some of them. If they don't, it's up to you to ask them why. I'm curious to find out why they don't do the testing. Maybe they're not so proud of the product when it comes to ISO testing. I don't know. Dispersion mastics or dispersion adhesives, which are mastics, they also have some special characteristics. So D stands for dispersion. And if you look right here, this is a D, I can't even see that. It's a D1TE. My glasses are going to need to upgrade my glasses. This is a D1TE. So D stands for dispersion, 1 stands for normal, T stands for slip resistance, and E stands for extended open time. Or you can go with an accelerated drying time. Only with D2 mastics can there be an accelerated drying time. And a D2 mastic after 7 days air cure and water immersion. And the product still passes the tests. So again, I am not the biggest fan of using mastics because they get used in the wrong spots. But if the mastic is what you want to use and it's the right product for the job, make sure you're using the right version of that mastic, a D1 or a D2. Normal adhesion for mastics is 145 on the shear strength. Normal adhesion for mastics after water immersion on a D2 is 72.5 and 145 at elevated temperatures. So this is standard testing, just room temperature, 72 degrees, 72 degrees, 50% relative humidity. This is now I'm messing with the temperature. I'm dropping it in water and I'm coming out and I'm pulling the test, or I'm going ahead and I'm elevating the temperature in higher temperatures and I'm still coming out with 145 PSIs. So this seems to me like a more extreme test method, but for me, if I was going to use a mastic on a wall in a shower and it was the right product to use with that tile, I would want to go with a D2. And then reactions and resins and epoxy resins. Epoxies and urethanes. R stands for reaction resin. There's a 1 and a 2 and improved, and there's a T and a slip resistance. For the most part, you're doing epoxies on the floor in commercial kitchens. Sometimes you're doing urethanes in certain applications over metal or stainless steel floors, or like in certain hospital scenarios or cruise ship scenarios where you're direct bonding to metal. The specification might call for a urethane or an epoxy, and you want to make sure that it's slip resistant. So if I'm going up onto a wall, I definitely want something that has a slip resistance, and I always want to go for the improved. Normal adhesion and reaction shear adhesion strengths of 290 PSIs. Now notice for a regular cement, the normal adhesion is 7250, is 72.5 PSIs. Now this has 290 PSIs, and this is for an R2 shear adhesive strength is 290 PSIs or greater. And with cement grouts, it's on the packaging. If you look here, If you look here, it's on the packaging. You'll see it. First thing, you'll see these badges on that packaging. This one, this is a CG2 WAF. So CG cement grout, 2 is improved. WAF basically hits all of these: reduced water absorption, high abrasion resistance, and fast setting grout. So it's a rapid setting, high abrasion resistance, and reduced water absorption in one grout right here. So just understand the ISO codes, understand where to find them, and then understand the application. I'm doing a water feature, swimming pool. I'm doing a commercial project. I definitely want to go with something like this. CG1 normal cementitious grouts, residential and commercial buildings, shower walls and floors. But I might want to think about bumping it up to the next level when I'm getting into some commercial projects, water, like again, swimming pools here, shopping malls. There's less pores per square inch of grout, therefore there's less opportunity for stains. Fast setting, I can get in and out. I can quicker turnaround on the jobs. Contractors can get on top of my floor faster and finish up their part of the work. And then reaction resin grouts are right here. There's an RG reaction resin grout, CQ, in this case, Carapoxy CQ. This is Carapoxy, and you can see their badges over here. And there's normal and there's higher performance characteristics than cement grouts. A CG2FAW. So CG is a cement grout, 2FA. The RG grout, an epoxy grout always has higher performance values than a cement grout. It's just maybe not as easy to work with. And but the one thing I will say about epoxy grouts is that the color you see in the bucket is going to be the color you're going to get. Commercial applications, chemical facilities, restaurants, airports, all of these places are great opportunities for that. And with that, I just want to finish up with, remember, you want to look for the product, want to look for the standards, you'll see them on the packaging. Whoever product you're currently using, if it doesn't have them on the packaging, you need to pick up the phone and ask them why. There's no reason after 10 years that they don't go ahead and have them on the packaging. The TCNA handbook felt it necessary to go ahead and put in all the ISO standards in the handbook. I don't understand why all my competitors don't have it on all of their packaging, not some of their packaging, all of their packaging. Remember, you also find what you need in the book. And again, the next time we do this, and I'm thinking 6 months from now, we'll do this again, and this will be a read along. We'll bring the book, I'll pull out several pages that we're going to go ahead and look into and get you guys a little more comfortable with how to find the proper mortar based on the installation that you're using. So with that, do you guys have any questions?
You're right. Thank you, Sam. That was awesome. I'm sitting here taking notes. I've learned a lot. Well, let's see. Let's open it up to questions. Give everybody a moment or two to type. And yeah, 6 months. That's about where we are in our schedule. We've got a lot of really exciting webinars planned. So the next year is going to be really good.
There's all the trade shows are opening back up fully next year. So we'll be attending all of those trade shows.
Yeah, exactly.
And it's going to be a busy schedule next year.
It is. It's going to be really busy. Here's a question for you. Hi, Sam. Where does the Flex Color CQ fall into the ISO grout specification?
Fantastic question. The same place it falls into the ANSI specifications. They have no clue how to go ahead and what to classify those products as. So right now, there really is no classification for it, not in ANSI and not in ISO. I'll just leave it at that. Certain manufacturers are fighting with each other about what to call the product is probably the best way to answer that question.
Here's how can I get the manual? So somebody's looking forward to the next webinar.
Yeah. Hey, if you can contact your MAPE sales rep, I think we can get you one of these. And this
Yeah.
happens to be a Mapei one. This is the 2021. You might want to wait for the 22s, but we have extra 21s laying around. They don't change that much. They changed a lot for a while, but they don't change that much. It has grown, by the way. When I first started in the business, it was about that thick, and now it's this thick. But there's just been a lot of, innovations and a lot of new application techniques. Think about when I first started in the business, tile was 12 by 12 inches. That was big tile. You used a 1/4 inch grout joint, and that was pretty much it. And then porcelain tile came out. Now we have these large and heavy tiles, gauge porcelain tiles. They're ginormous. I seen 5 foot by 12 foot tiles out there. It's 7 millimeters thick. And all these specifications are being added every 2 years into the book here. So you can get it, I would contact your local sales rep and have him pick one up for you and give it to you, because we want this information in your hands. This protects you as the installer, by the way, and it opens up the door. This is not every installation method out there, but every installation method in the book is a proven method. Does that make sense? Because there's always some other methods, but every installation method in this book also works in Alaska, New York, Florida, California, Texas, Kansas, Hawaii, wherever you're at. Whereas some of the other installation methods that are out there might be regional to your area and might work just fine. It doesn't mean if it's not in here, it's wrong. But what's in here is definitely right.
That's awesome. Thank you. Oh, and follow up from this gentleman.
Mhm.
He's a super fan of our products and he wants to get certified from Mapei Technical Institute. So there you go. There you have it.
Awesome.
That's love to
That,
hear it. Thank you, sir.
yeah,
That
thank you.
is that's amazing. Um, yay. That's good news. Love to hear that. Um, all right. Well, give everybody a little bit more time
Okay.
to type just a little bit here and see if there's anything more. Um, so yeah, like we were saying, very full schedule for the new year, and contact your reps, get the books.
Yep.
We'll
Yep. We'll do a read along together. Well, I just
I'm
think
looking
for
forward
too
to it.
long, honestly, I feel like for too long, the book has been available and nobody's ever really taken the time to walk people through, connecting the book and product together. And so the next one will be more product specific. I'll literally go, we'll pull up a standard, or we'll pull up and this one, on ground concrete with electric radiant heating. It has ANSI 118, 6. It has a C2 S1 or better. We'll actually go through the products that meet that standard and the ones that we would recommend for that.
That
And if
sounds
any
really
of my
good.
competitors are listening, by all means, do the same. Go ahead and show them your ISO standard products that meet that standard. All right. Well, listen, everybody.
Yeah, absolutely.
Yeah, everybody listen, thank you very much. If you're currently using our products, thank you. We appreciate your business. If you're not using our products, I think you need to give us a chance. I promise you, you will not be disappointed. This last couple of years has been a interesting time, but I feel very strongly that it's moving forward and we're moving away from that time and we're getting back to what we were used to call normal. And I'm looking forward to that with my heart and my soul. I hope everybody's safe. I hope everybody's healthy. I look forward to seeing everybody at one of the trade shows coming up. The NWFA, coverings, surfaces, World of Concrete. Looking forward to seeing you at any and all of those shows. And with that, thank you very much for tuning in and taking your time. I know how valuable it is and I appreciate it. So thank you.
Exactly. Thank you, Sam. You took the words right out of my mouth. And again, we invite you to visit the Mapei Technical Institute pages and to check out other videos if you've enjoyed watching Sam today, because we have multiple videos starring this gentleman. He is just a wealth of information. So please, and thank you again for joining us. I'll echo Sam. And thank you. We'll see you next time. Be sure and reach out and get those books, okay? Have a
See
great
you.
rest of your day, everybody.
Yep. See you.
Bye-bye.
Bye.